Okay, so my talk is about building information modeling and the use from an operations management perspective. I want to start out with a question. We have here two persons quite famous, and I want you to consider for a moment, what do these two persons have to do with building information modeling and operations management? On the left we have Johann Gutenberg, and on the right we have Henry Ford. I'm not going to tell you the answer right now, but you will soon find out. First, let's consider why is operations management needed in the built environment. Operations management seeks to improve performance by increased reuse of designs, processes, and information. And if we look at the built environment, it's a setting where operations management innovations is sorely needed. If we consider building projects, the designs of the buildings are not much reused. So when we have especially large-scale building, the different subsystems and the buildings themselves, they are always redesigned. Then if we look at the process, the participants in projects, they change. So we don't have the same participants. And then it's also difficult to have processes which you can reuse and develop. And then lastly, information on the performance of the buildings is not collected. And if it's collected, it's not really used then to improve the building and the built environment. So as you can see, there is a need for operations management innovation in this area. And we can see that through the fact that in this industry, when we increase scale, then quality often goes down, costs go up, and it takes more time. Everyone has heard this cliche or anecdote, whatever you want to call it, that a building project is over budget over time. And also, if we look at buildings, as they age, they become increasingly difficult to maintain and upgrade. So when we want to upgrade an old building, it's more expensive and more complex than for newer ones. So what does operations management have to propose in this respect then? How can we reuse and improve designs and processes? Well, the basis is tools. Reuse and learning in operations management is based on tools that allow designs to be modeled and copied and processes to be repeated. And if we have a tool, a modeling and copying tool, then it's possible from a design to produce interchangeable parts, and these can be combined with other parts in standard processes, and these parts, they can also be exchanged for new ones when they wear out or become outmoded. So here is where Gutenberg comes in. Gutenberg's innovation, the printing press, it's a paradigmatic modeling and copying tool. So Gutenberg, he models a page from a manuscript with the movable types, and then he can produce many copies using this set page. And the important thing here is that the as designed is exactly as produced. And you don't need skill. You know, you replace the copying skill by a tool. So if you consider the situation before Gutenberg, if you wanted to have one more book, you needed an expert in reading and writing. And this expert, he had to read the manuscript, and then he had to write a copy. And if you have a lot of books, then you will need a lot of reading and writing experts. And what happens when we want to have, let's say, a print of 1,000 Bibles or something like maybe the Catholic Church wanted to have? Well, the unit cost of books, they will go up and the quality go down, because the available experts in reading and writing, on average, they will be making more mistakes and they will be taking more time. So what does this have to do with the built environment? Oops, wrong. So in the built environment, we have a very similar situation. When we build a new building, we need an expert to read the blueprints. And then it's translated into a building, but it's based on skill, this translation. So you don't have this modeling and copying, and when you increase the scale of the building project, you will need more experts. These experts will make more mistakes, and they will take more time. So here you have a partial explanation why in the building and construction industry, when you have a larger scale project or when you have more projects, then the quality tends to go down and the costs go up. Okay. What does Ford have to do with this? Well, Ford, his innovation is that he's most well known from is the assembly line. So assembly lines, they are also based on modeling and copying tools. You can make car parts by machine tools which are made to specification, and you can combine them into cars on an assembly line. Okay? And when you do this, you don't need very skillful people working on the assembly line, because they are interchangeable standard parts. And so you are not in the situation like in the book business before Gutenberg or in the building business that you are reliant on skills. But if you are not reliant on skills when building the car, you have these standard parts. Also, when the car starts wearing out, when you need to change a part or you need to upgrade it, then you don't have to rely on high skills either, because you know that the car that was built, it's also exactly the car that you maintain. And this is the basis for very significant business in industries such as mechanical engineering, where many companies, they make more than 50% of their business in the after sale to maintain and upgrade products. And in the building industry, there is also an interest to move in this direction, but there is a challenge, because in the building and construction industry, the building that was designed, it was not the building that was built. And then when you want to maintain it, you have the challenge that you need experts to come and interpret and see that, okay, this building now that I want to maintain, what does it really contain? What sort of a building is it? How can I maintain and upgrade it? Because there is missing information, there is, well, missing knowledge, and then you need to fill that by experts. So you have a situation where if you want to go into the service business, as many of the mechanical engineering companies have done, you are in a very bad situation, because when you grow the business, then your costs will start going down, going up, your quality going down, and it will all take more time and so on. And you can't really build a very good service-based business in such an environment. Okay, where does building information modeling come in then? Building information modeling, it's a set of tools for representing the building as it's designed, built, used, maintained, owned, sold, and so on. And the model that we have for designing it, it's reused in the building phase and updated and improved. And based on that, we also transfer a model, reuse it for making energy simulations and such things for the as-used phase, and on to the as-maintained. So here you see that we are in a situation where a model over the life cycle of a building is reused for different purposes. And this means that there is an incentive and possibility that you can start investing more in these models because they are reused for many purposes, which if you don't have this situation, there is no point or incentive. Then the other thing is also that these type of tools, they also enable you to run virtual simulations of what will happen when you combine different subsystem design or when you take a building into use as such. So it's potentially a platform for new types of services over the life cycle and also for coordinating efficiently the operations of different actors in the building business. Let's look at an example. This has to do with creating something new. So in the heating, ventilation and air conditioning, we have manufacturers that create models of their products. And then we have engineering designers who use these models. They use them free of charge. And these models, they include properties that are needed for energy simulations, and they enable improved designs of building systems and selection of better solutions and equipment for the buildings to get benefits such as reduced energy usage or better air quality or living environment. And this use of these object models, it encourages the manufacturers to invest in developing more and better object models. And if you look at this type of activity, Finland has been on the leading edge. So we can find two providers of such tools and processes in Finland. One is Progman, which is a software company based in Rauma, but it's one of the leading companies in the world in this domain, and Granlund, who has been one of the pioneers in developing energy simulations into a valid, viable business model. So we can see that the building industry in Finland has been in a special situation in its ability to start reusing designs in repeatable processes to find energy efficient solutions. If we look at this from a service supply chain point of view, what it looks like is that we have hundreds of manufacturers like Flechtwoods, Halton, and so on, that make different types of equipment, and they make the models. They use Progman's tools to make these product models, and Progman, the software provider, the tool maker, they distribute these models so that engineering designers like Granlund can take these models and use them in energy simulations to find out what's the best solution for a building project. There are many more examples of leading BIM tool makers and users in Finland. For example, we have Tekla and Solibri, who are tool makers for structural design and subsystem integration. We have Skanska, the subsidiary in Finland, which is leading in using BIM-based operations management in construction, and they got a prize for the best BIM-based construction project recently. And then we have Senaatti, an owner of property, who has been a destination for researchers interested in the use of building information models by property owners and facility managers. So there really is an opportunity for making leading edge innovative research in this domain in Finland, based on the environment that we are in and the progress that industry has already made. So to make best use of this situation, there is an aalto BIM initiative where the goal is to make building information models a platform for services such as building space customization, sustainable design and use, lean production, and asset value preservation. This is a multidisciplinary initiative. We have design and construction, operations management, and information systems professors involved in this initiative. There are 2 tenure track professors, myself and Dr. Vishal Singh, who is in design and construction. Then we have a professor of practice who will hopefully soon be appointed, who will help in setting up and doing real-life experimentation and testing out innovations in practice. And then we have a FIDI Pro professor where funding has been approved, and he will join us in the spring, Dr. Lauri Koskela from Salford University, who is an expert in lean construction. And the first thing that we will be looking at is combining energy simulation, performance monitoring, and improved maintenance practices for value management. This is a cross-disciplinary task where we will need all the elements which have been brought together in the Aalto BIM initiative. Okay. Thank you.